Hi there, this is AGNR 131, and this is Lab 8, Part 2, Part 2B. Part 2A, we just saw that one. That was the ion movement in soils, where we looked at the different colored dyes that had different charges. This is going to be a very similar one. We're going to look at it from a different point of view and say, how does soil actually keep the good things in there? Might have already answered that question if you already looked at Part 2A of this Lab 8. But Part 2B which is called Soil Has a Charge. That is the key to how fertilizers, pesticides, things that we want to stay in the soil, that's the key to them staying in the soil. So let's have a look and see if we can demonstrate with a battery, 6-volt battery, some copper wire to generate a charge. We're going to actually try to look at an electrical charge in soil. So two different soils. Again, these are the same ones we use for the dye experiment. One's sandier and one's clayier. And we're going to actually get them together and mix them up with some distilled water, make a slurry out of them. And then we're going to actually see if we can determine whether soil has a positive or a negative charge. Okay, so we've gone ahead and made up our slurries of the two different kinds of soils. We made them pretty loose. There's a lot of water. They're pretty runny. So we want to we've actually got our 6-volt batteries hooked up to copper wire to the negative, copper wire to the positive. We put both of those ends in our solution here of soil and distilled water. And now we're going to have to wait a little bit, and we'll just have a look and see if anything happens to the copper wire ends that are in this solution. So if we're operating on the basis that soil has a charge, and we're putting forth a negative and a positive current, if you will, positive charge into the soil, we would expect that if soil does have a charge, that since opposites attract, there should be something on one end or the other of the copper wires that would indicate that soil is being attracted to that. The clay particles in particular are being attracted to that, because if you remember, that's the particle that is charged in a soil. So let's go ahead. You've kind of seen how it's set up. Let's go ahead and see if we get any action after about 10 minutes or so. Okay, so we've waited about 10 minutes, and you can kind of see, especially with the clay one, that there's some action going on in there. We haven't pulled the leads or the wires out of here yet, so we really don't know for sure what's going to happen. But remember, we've got a negative lead and a positive lead. So we're trying to prove that soil has a charge. So here's a sandy one. Let's go ahead and pull the negative lead out first and see if we can focus on anything on the bottom of that. So here comes the negative lead. Zoom in on that. Looks pretty clean, right? Okay, so that looks pretty clean. I'll go ahead and put it back in there for now. Let's go ahead and pull the positive lead out of this sandy one. Well, there's a little bit at the end of that, I suppose. Remember, this is a sandy soil, so what do we know about sandy soils? Typically, maybe not a whole lot of clay in there. I'm going to go ahead and dip the negative one back in again, and let's just pull it out and have a look. There it is again, pretty clean. So I would have gone ahead and put the positive lead back in there and move it around just a little bit, and then what do I get? Well, it's still kind of the same. It's definitely not clean. It's definitely got some stuff stuck to it. Let's go and see if over here on this clayey one, if there's any difference. So go ahead and let's zoom in on that. You can kind of see this is the negative one here. It's got a lot of bubbles going on. We've been kind of watching it, and there's just a lot of bubbling action going. Every now and again, you get like a little bloop 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 of the bubbles. Let's just see what it looks like on the end there. Well, you can see just a little bit of material, but it looks relatively clean. Let's go ahead and pull the positive one out and see what we get on that. Oh my, look at that. There's all kinds of stuff on that. Quite a bit of stuff going on. Remember, this is a slurry, so we actually had a lot of weight coming off the end of that, but that was really quite dramatic. Let's go ahead and try that again. Let's move it around in there, and again, that was sitting for 10 minutes. I don't know what's going to happen if we just pull it out, but you can see if you focus in there, that negative has got a lot of bubbling action going on. There's a lot of bubbles around it. I'm going to go ahead and pull that one out again, and you can see just a kind of a blob on the end of that. That could be on the bottom if I just shake it a little bit. Yep, it's got just a little bit, not a whole lot. But what's happening with this one again? Pretty good. Not as much as before because it hasn't been in as long, but pretty good coat all the way down on that from the depth that it was inserted all the way to the bottom. It's completely surrounded with soil particles. And if I shake it a little bit and pull it out again, we still have it pretty coated all the way down. That's just dipping it in, shaking it, trying to shake everything off and putting it in there. If I do the same with the negative one on this, if I shake it a little bit, well, in this case, it actually looks pretty much the same. But the first one you actually saw when it actually sat in there, and you can see it again. It's thicker than the other one, just sitting there. So if I leave this to sit in there for another couple minutes, that positive one looks like it's going to continue to have a lot more particles, especially attached to that positive lead, especially with the soil that's got more clay in it. We can go back over here one more time and look at this one. Here's the negative lead on this, the sandy one again. It's pretty clean, right? And then let's just see what this guy does. There's still material stuck on it. It's definitely not as dramatic as the other one, but if you compare them both together, you might be able to see a difference in them. One of them is really quite clean. The other one has got dirt on it, has got soil material on it. So, and then finally, let's go ahead and make the final comparison with these two. Over here, I've got this one. Let me see if I can pull it out. There's our negative lead, and then so I can get our positive lead out. And there's our positive lead on that one. So again, not quite as dramatic, but if you look at the depth of insertion, there's quite a bit more stuff on that. Definitely not as dramatic because it hasn't been in as long as the first one. So go back to that first one. That's really the reaction that we were actually looking for on this. But you can definitely see there's a difference between the material on this and the material on the other one. Some of that actually is if we shake the water off, we can still see not a huge difference now, but you did see what happened when we left it in there for quite some time. So that kind of concludes the demonstration. Hopefully it makes some sense to you and you can draw some conclusions from that. Thanks.